All right, we're back with this equation that I had up just a second ago. And what I've got is 2 sine squared minus cosine t equals 1. Now, if that sine squared were cosine squared, I could use my same technique. Well, I can do that. Because remember that I know that sine squared t plus cosine squared t equals 1, which tells me that sine squared t equals 1 minus cosine squared t. So now instead of writing 2 sine squared, I'm going to write 2 times 1 minus cosine squared t minus cosine t equals 1. Let's do a little work here. So I've got 2 minus 2 cosine squared t minus cosine t equals 1. Let's move everything to the right-hand side. So I'm going to end up with 0 equals 2 cosine squared t plus cosine t minus 1. This will factor as 2 cosine t minus 1 times cosine t plus 1, and that equals 0. So that means that 2 cosine t minus 1 equals 0, or cosine t plus 1 equals 0, which means cosine t equals 1/2, or cosine t equals -1. We can do that. Cosine is 1/2 at pi over 3 and 5 pi over 3, and cosine is -1 at pi. Yes, that's correct. So that means t equals pi over 3, pi, and 5 pi over 3. Okay. All right, so this is just about as hairy as it's going to get. And you might be thinking, well, I'm just going to plug that sucker into Desmos and touch the intersection points. And that will get you partial credit, but there's probably some exact answers in there, and the only way to find the exact answers is using the algebra. So let's see what we can do here. All right, so let's turn everything to sines and cosines. So I've got 4 divided by 1 over cosine squared theta plus 3 cosine theta equals 2. Cotangent is cosine over sine. And tangent, is sine over cosine. That's handy because these cancel. So what I really have here is 4 cosine squared theta plus 3 cosine theta minus 2 equals 0. Let's put that in something more familiar. So let's let u equal cosine theta. So I've got 4 u squared plus 3u minus 2 equals 0. That will not factor. And how do I know that won't factor? Well, because when I try to make something factor, I think about the AC method. And the AC method says take 4, multiply by 2, that gives you -8. And now try to think of factors of -8 that are going to add up to make 3. And there aren't any, so this isn't going to factor. So what are we going to do? Well, we're going to use a quadratic formula. So u is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So what that really means is that cosine theta equals 3 plus or minus the square root of 9 plus 32 is 40 all over 8, which really means that cosine theta equals 3 plus square root 40 all over 8, or cosine theta equals 3 minus square root 40 all over 8. I really want theta, so let's bring out my Desmos. All right, so 3 plus square root 40 over 8. Oh, that's bigger than 1. So we'll toss this guy out because that's not possible. So what about 3 minus? That's okay. All right, so now how do I find theta? Well, I find theta by taking the inverse cosine of this. And let's just do it this way. I think Desmos will let me do this. Yes, it will. So theta is 1.9994. Now, that's not the only angle that has that cosine though, is it? So I'm here somewhere. There's another angle down here. I get there from 2 pi minus. So theta is 1.9994 and 4.2838. And those are my solutions. All right. So in this section, I have only used the identities that we've already encountered in this course, and I just put them here for summary. And in fact, really the only ones I used were these and these. These guys are nice, but they're actually honestly completely optional because you can get there from here, and that's what I do most often. Same thing for the rest of these. I will use these, and I will get the rest of them from these two. So focus on the sine and cosine identities, and that will help you make your life a little bit simpler. All right, I'll talk to you again soon.